Hello once more. Today we shall treat the second lesson under the topic waves, which is the categories of waves. I assume that you know what actually a wave is and what it does to the particles of a medium when it passes through. There are so many types of waves that exist, some of which are radio waves, water waves, microwaves, sound waves. You can even name the rest. But all these waves fall under two categories, which are mechanical waves and electromagnetic waves. Now remember that we defined a wave as the disturbance that can either travel through space or matter. Their mode of travel is actually what distinguishes the two categories of waves. Now, which of them do you think travels through space? And which do you think travels through a medium? Electromagnetic waves are those disturbances that travel through space. They do not need a medium to travel through. If an electromagnetic wave wants to leave point A to point B, it does not need any medium, be it air or water, to pass through. As can be seen in the figure in front of you, figure 1, it displays the different types of electromagnetic waves. You have the radio wave, the microwave, the infrared, visible light, ultraviolet, X-rays, and gamma rays. All of these names are probably familiar to you. The different types of electromagnetic waves, as will be seen on the figure in front of you, are classified from left to right in order of increasing frequency and decreasing wavelength. That is, reading from the left to the right, from radio wave, microwave, infrared, visible, ultraviolet, X-ray, and gamma rays, the frequency increases while the wavelength decreases. This is to say, of all the electromagnetic waves, gamma ray has the highest frequency, while radio waves have the lowest frequency. But gamma rays have the lowest wavelength, while radio waves have the highest wavelength. Now, given the definition of electromagnetic waves, as said earlier, that they are waves that travel through space. That is, waves that don't need a medium to travel through. Can you actually define a mechanical wave? There are two key points about waves. They can either travel through space or through a medium. And if mechanical waves travel through space, it means electromagnetic waves can travel through a medium. But our definition is that electromagnetic waves are waves that travel through space. Then that leaves us with the other definition of mechanical waves, which will be waves that travel through a medium. Mechanical waves cannot travel through empty space, through a vacuum, never. If there is no medium, that is air or water, then mechanical waves can never be transmitted from one point to the other. So mechanical waves are those waves that travel through a medium, air or water. Example being water waves, sound waves, or waves produced by either compressing a spring or stretching the spring. Mechanical waves are of two types, that is longitudinal waves and transverse waves. What are longitudinal waves? These are waves that move in the same direction as that of the disturbance. Examples being waves produced by compressing a spring or stretching a spring, sound waves. And now, when we say the waves travel in the same direction as the disturbance, it means if the disturbance is moving from left to right, then the wave produced too will move from left to right. Look at the figure in front of you. You can see the red arrow indicating the direction of energy wave, that is the direction of the wave produced, and the black arrow in the spring indicating the direction of the spring when it is compressed and released. The wave moves in the forward direction from left to right, and the spring also, the coils of the spring, they also move in the forward and backward direction. So the wave and the coils of the spring, they both move in the same direction. That is why we say these waves are longitudinal waves, because they move in the same direction as that of the disturbance. Now, talking about transverse waves. Transverse waves are opposite to longitudinal waves. If the wave produced is moving from left to right, then the disturbance is moving from up to down. That is, transverse waves move perpendicular to the direction of travel of the disturbance. If a spring is made to move up and down, then the wave that will be produced by that spring will move from left to right. Their directions will be perpendicular. Examples of transverse waves are water waves or waves produced by fans in a stadium. Look at the figure in front of you, figure 5. You see the blue arrow indicating the direction of the wave. The wave is traveling from left to right, but the disturbance is moving up and down, up and down. So they both cut at a perpendicular direction. So transverse waves move in a direction perpendicular to the direction of travel of the disturbance. These two pictures can give you a good distinction between transverse waves and longitudinal waves. You look at the first one, the wave is moving left to right. Meanwhile, the spring itself is moving up to down, up, down, up, down. But in the second diagram, the waves are moving left to right, while the coils of the spring are also moving left to right. The first diagram shows the direction of transverse waves, while the second diagram shows the direction of longitudinal waves. So, what difference can you give if you are asked between transverse waves and longitudinal waves? What can you actually say differentiates them? Now, transverse waves move in perpendicular directions to the disturbance, while longitudinal waves move in the same direction as the disturbance. Another difference is that in longitudinal waves, you have compression and refraction. That is compression and expansion. But in transverse waves, we have crests and troughs. Those two are the main difference between transverse and longitudinal waves. The differences are summarized in the figure in front of you. The first one indicates longitudinal waves. You can see compression. The coils of the spring are close together, but refraction, also called expansion, shows how the coils of the spring are far away from each other. You go to the next figure, figure 2, showing transverse waves. You can see that instead of compression and refraction, what we have is crests and troughs, with the crest being the highest point and the trough being the lowest point. This is a generalized distinction between transverse waves and longitudinal waves. Below is what you can actually call a general summary of waves. That is the categories of waves, examples of waves, and the types. From waves, the arrow goes to electromagnetic and mechanical. That is to say, we have two categories, electromagnetic and mechanical. Mechanical waves, in turn, are divided into two different types, transverse and longitudinal, with example of transverse waves being water waves and waves produced by oscillating springs, and example of longitudinal waves being sound waves and waves produced by compressing springs. There is a difference between compressing springs and oscillating springs. Oscillating springs can move in the up and down motion, but compressing springs move from left to right, so don't get confused. Examples of electromagnetic waves, we have X-rays, microwaves, infrared, radio waves, gamma rays, and light waves. We come to the end of our lesson. In our next lesson, we shall be talking about associated terminology. That is the various terms used in waves.